generally speaking, triple integrals are not easy to deal with. We'd much rather deal with iterated integrals because that allows us to solve integrals one at a time and work our way backward. So how do we do this in triple integrals? Well, it turns out that it's very similar to the way we did with double integrals, but there's an additional layer because it's triple. So if we look here, if we can say x is bounded by some constants, so x varies from a to b, no, it's not a function of anything else. And if I can define y in terms of x, much like we did with double integrals, where we said, all right, x goes from one value to the other, y goes from some lower bound as a function of x to an upper bound as a function of x. And now z has a lower and upper bound, but z is bound not only by x, but it's bound by y as well. So it's a function of both of them. If you can show these three properties by defining your region, then if you have some continuous function here, instead of having to think about a triple integral in the standard form, we can use this iterated integral form and say, all right, well, I'm going to solve this integral here, substitute in the x and y values, then I'm going to solve this integral here, do the integrate in terms of y and plug in the x values, and then I'm going to integrate here in terms of x. So you're going to do the standard things that you normally would do with a double integral, except you just have one additional layer. Now, there's also a little bit more complexity here because when we did iterated integrals for two variables, you either integrated with x first and then y, or you integrated with y first and then x. But because then we now have three options, there's actually 6 ways we can integrate. We can go x, y, then z, or x, then z, then y, or y, x, then z, y, z, then x, z, x, then y, z, y, then x. So you can do all the different permutations, and for those of you who've studied anything about permutations, you'll find since there's 3 options, our total permutations are 3 factorial, which is 6. So if we were doing a quadruple integral, for instance, you'd actually have 24 different ways you could do iterated integrals. So this thing can get complicated rather quickly. And briefly, I want to go over some properties. These are things that were true for double integrals, but let's just go ahead and talk about them for triple integrals as well. If we have a constant, we can bring it out to the front. If I have two functions that or I can break up a function into 2 pieces, then I can integrate them separately. Again, we do this a lot. We don't think about the fact that we do this. Like if I'm integrating 2x plus 3, I'm usually integrating 2x and I'm integrating 3 or anti-deriving them and putting them back together. I don't think like I'm doing that, but I'm actually doing that. So this is an important result. And then finally, what this shows is I can break something up over 2 regions as long as those 2 regions add up back to the original one. So when would you want to do that? Well, there's a lot of cases you'd want to do that. To jump ahead maybe a little bit, there might be a region. Let's suppose you have something where you have a cylinder, and then on top of that, you've got sort of these, I think like bent angles, almost like a tube that has flaps that come out. Well, those flaps that come out are much more rectangular, and the tube is like a cylinder, so you might actually slice it into this piece and use something like cylindrical coordinates, and on these pieces you could use rectangular coordinates. That would be kind of wild. Another thing that's common to do is all the cases where f is positive, you do in one integral. All the cases where f is negative, you do in another integral, because you might want to be showing something in particular. So this happens a lot. So just keep in mind that we do this all the time. We do this all the time without thinking about it. And this has very specific applications for why we might want to do it. So in the next, or in the coming sections, we're going to actually compute some triple integrals.